Hi again, everybody. Here is a quick video to help you on learning how to solve percent applications. Once again, I'm going to be using the 5-step method that you saw in my video for section 3.1, and I'm hoping that this will help you as you work on your homework this weekend. So I'm going to start with the You Try It 3.30, which comes after example 315. Kim had lunch at her favorite restaurant. She wants to leave 15% of the total bill as her tip. If her bill was $14.40, how much will she leave for the tip? So remember, when I read a word problem, the first thing I'm asking myself is, what am I supposed to find? Find the amount Kim, I'm not sure how to pronounce this name, I haven't seen it before, should leave for a tip. Step 2. Well, why don't I let X equal the amount of the tip? Now, how does this work? Step 3 is the hard part usually, writing the equation, right? So it says she wants to leave 15% of the total bill as her tip. Okay, so let me just write that in English first. The tip is 15% of the total bill. So the way that percents work is that it's going to be a percentage of something. And the of in mathematics translates into times. I'm going to put a little dot here. Okay. 15%, we can write that as a decimal very easily. So I guess if I use parentheses, I won't need the dot. The tip is, well, the tip is the verb, that's equals. The tip we called x. So x is 15% times something. Maybe we were given the total bill. Let's take a peek. Yeah, the total bill was $14.40. So maybe I'll just write times $14.40. I'll put that in parentheses as well. So I have 0.15 times $14.40. So this equation is, it's almost solved. I just need a little calculator. And so I got that x is 216. So I just did step 4, right? I just did step 4. That's to solve the equation. And then the final thing is to answer the question. So step 5, the tip is, and now I'll put my dollar sign symbol, $2.16. And by the way, just a little tip about leaving a tip. I can remember this growing up because we were always taught 15% was a reasonable amount. 20% is a really generous tip for a restaurant. But, if the bill is $14.40, right? So 10% would be, you just move that decimal place one place, $1.44, right? And so if you can compute a 10% tip, and you don't want to give someone a 10% tip, another 5% tip would be half of that. So half of $1.44 is 72 cents, right? Half of 14 is 7, half of 4 is 2. So another way to come up with a 15% tip if you're in a restaurant is to take the last decimal off, so call it, instead of $14.40, call it $1.44, and then add half again as much, 72, right? And so now I have $2.16. And so you probably leave 2 1/4 or something, right? We're going to round up when we leave a tip. Okay. So that's a little advice, and that's problem 13, is 3.30. Let's move ahead. So in 3.32, let's try a similar approach. Let's write down using our 5 steps. What are we trying to find in step 1? Well, down here is the question. I'll just jump right to that if I can. What is the total recommended daily amount of sodium? So find recommended daily amount of sodium. I will let X equal the recommended daily amount of sodium, because that's what I'm trying to find. So now, step 3, can we write an equation? One serving of rice has 190 milligrams of sodium, which is 8% of the recommended daily amount. So 190 milligrams is 8% of the recommended daily amount. And again, writing that choppy sentence can actually help, because now I can translate that like I did last time. So this is equals, and we have 190. 8% of, so I'm going to write 0.08 times what? Well, the RDA, we're calling that X. So here's my equation. 190 times 0.08x. Step 4. Well, with a calculator, this is simple to do step 4. To get the x by itself, you can just divide both sides by 0.08. The 0.08s will cancel here, but like I said, with a calculator, that's going to be easy. So let's do 190 divided by 0.08, and I got 2,375, right, is x. And notice we were working in milligrams before, so I think that's going to be the idea here. So for step 5, the recommended daily amount of sodium is 2,375 milligrams. Okay, the next one. This time we're going to do 3.34. Same steps. Start by asking, what are we supposed to find in this one? What percent of the total calories are from fat? Interesting question. So, again, looking at what we have here, find the percent of total calories from fat. Right? I mean, really, the question says, what percent of total calories are from fat? That's what the question says. So step 2, I'm going to let x equal that percent. And now in step 3, I'm trying to write an equation. So if I put that verb back there, what percent of total calories are from fat, that's the sentence that I'm trying to translate. So what percent is what I'm looking for? I'll call that x, times the total number of calories, I don't know yet, I'll have to look, are from fat. So maybe these are things that are in the problem. Let's take a look. Okay. Each brownie is 190 calories, and 76 calories are from fat. So I guess we do have what we need. 76 calories are from fat, 190 calories are the total calories in a brownie. Okay. So step 4 is to solve this. X times 190, so to undo that, we will divide by 190 and cancel. And so I get x equals, well, it's 76 over 190. So if I type in 76 divided by 190, I get a decimal, 0.4. Now remember, x was the percent we are looking for, but it's written as a decimal right now. So for step 5, I will answer the question by saying 40% of the calories in the brownie are from fat. Cool. So that's enough of 3.34. Let's go look at another example. We're going to talk now about percent increase. Okay, and I might talk about this, percent increase and percent decrease. So there's a little idea that I like to get across here. When you talk about percent increase or decrease, is always a percentage of the original amount. And again, we learned that of means times, right? So I think this can help. And maybe the other thing to keep in mind is that what happens in these problems is you have an original amount plus the increase, that's your new amount. If it's decrease, as we're going to see in probably the next example, we would have original amount minus the decrease is the new amount. So let's see how this goes. So if we're looking at 3.36, we want to find the percent increase. Okay. Find the percent increase. Let x equal the percent increase. Fine. Let's see what else it says. In 1995, the standard bus fare was $1.50. In 2008, the standard bus fare was $2.25. So the way this works is the original amount, well, they gave me that, right? The original amount we said was $1.50. Plus the increase is the new amount, $2.25. Now, do we know the increase? I guess we don't. I could call it y, I guess, or something. But it's very easy to see that y is 75 cents. So the increase is 75 cents. So now we want to know what percent of the original amount is the increase. That's really the problem I'm solving. So let's see how this worked. Let x equal the percent increase. That's x times the original amount was 150 is the increase. Now we worked out that the increase was 75 cents. Okay? So we can solve this equation. X is 0.75 divided by $1.50. Because again, if you were to, I'll get rid of this for now, but if you were to divide both sides by $1.50, that'll get the x by itself. Now over here, I have to do 75 cents divided by $1.50. That's going to be 1/2, right? 0.5 if you work it out on the calculator. But what percent would that be? That's a 50% increase. And actually, you could kind of verify that makes sense. You had $1.50. If you did a 50% increase, that's another 75 cents. And so that's how we got that. Let's do a percent decrease problem. I think they have one coming up here. Let's try 3.38. Find the percent decrease. Last year, Sheila's salary was $42,000. Because of furlough days this year, her salary was $37,800. So we had 42,000. But this year, because of the furlough days, she lost a lot, right? Oops, sorry about that. So minus the decrease is 37,800. Okay, so how much of a decrease was it? Well, I guess we could do 42,000 minus 37,800. That's the decrease. I'll go ahead and type that in the calculator. 42,000 minus 37,800. So it was a decrease was 4,200. That's how much the decrease was. But what we're supposed to find, and I kind of skipped this, right? Well, I said it, I didn't write it. Find the percent decrease. So in step one, we needed to find the percent decrease. So again, if they tell me to find the percent decrease, it's kind of two steps, okay? First, find the decrease. Well, we did that. 4,200. So now we answer the question. What percent, it's always a percent of what? Of the original amount is the decrease. That'll give me the percent decrease. Or percent increase works the same way, right? So the original amount this time was that 42,000. What percent? Well, we don't know. So actually, step two, we would let x equal the percent decrease. And so 42,000 times x, right, is the decrease 4,200. And so to get the x by itself, we can divide both sides by 42,000. And you're going to get 0.1 if you work that out on a calculator, 1/10. And so what percent of the original amount is the decrease? This is my step 5 here because we just did step 4. This is a 10% decrease. So these percent decrease and percent increase problems are two steps. First, you need to figure out the increase or decrease and then ask what percent of the original amount is that decrease or increase. And we got it. Okay, the last set is talking about simple interest applications. And I think you'll be okay if you just use this formula, I equals PRT, to help you write the equation. Maybe I'll do example 320 and then we'll call it quits. Okay, so let's see what we're trying to find. How much interest will Nathalie earn in 5 years? Okay, so again, 5-step approach. Step 1, find the interest earned in 5 years. I'm going to go ahead and let capital I equal the interest because for these simple interest problems, the formula is I equals PRT. PRT, principal, rate, and time. So that can allow me to write an equation. Okay, we're trying to find the interest rate. We don't know that. But hopefully we know the rest of these. Let's see. The principal was $12,500. That's how much he deposited. Let's see if we can find the rate and the time. Oh, the time is 5 years. You want the time to be measured in years because the rate is what's called an annual rate, 4% interest. So that means each year you earn 4%. So I'm going to write that as a decimal, 0.04. And we do that for 5 years. And so let's see what happens here. 12,500 times the 4%, I'll write as 0.04, times another 5. And so we would earn $2,500 extra dollars of interest. Okay, so $2,500 interest would be earned. So I hope that these samples that I worked out will be helpful to you as you work on your own percent problems this weekend. Bye for now.